Good morning, class. So today is Tuesday, November 10th, and before you take your quiz, you guys are going to answer this bell ringer question. So it says, using the word bank below, put the electromagnetic spectrum in order from largest wavelength to shortest wavelength. So hit pause as you fill this out. I am going to reveal the answers for you, but I want you to try this on your own first. So hit pause. All right, so you should have filled this out on your own because that will only benefit you for your quiz to see what you know. But the correct answers are, so if I start with the longest wavelength, that will be your radio waves, followed by your microwaves, followed by infrared waves. Smack dab in the middle is visible light. And then we have ultraviolet waves, X-rays, and then gamma rays is the last one. All right, so today you guys are going to take your quiz. I want you to do that first. Make sure everything else is shut down, no notes out. There's 10 questions altogether, all multiple choice. Then once you're done with your quiz, you are going to come back. So hit pause on this video, but come back. I'm going to have a couple videos to show you about concave and convex mirrors. A really cool video showing you the focal point and how the image flips upside down, and then a brain pop video on how the eye works. All right, so hit pause to fill out your quiz and then come back. All right, so you should have taken your quiz already. So here is the sound and light quiz. You should have taken that. What I want to do first, before we move into talking about the eye, I want to review our lenses. So we have concave mirrors and convex mirrors. Remember, concave focuses all the light back towards the middle and we get this focal point. And if you're beyond the focal point, the image is upside down. If you're inside the focal point, the image is really big and right side up. So let's take a look at this video real quick.
This is a demonstration of the image formed by a concave mirror.
Not the one I want. Why do I have it twice? So let's go back. Okay, here we go.
The one intention for this lesson is that you will understand how light is reflected off concave and convex mirrors.
So we're looking again, I'm kind of speed through this because I want her to show you light rays shining and what it does on the mirror. So that's what I'm really showing you here.
Here I've got a round mirror. Now both sides of this have been mirrored, and if the light is going to hit the inside here, we say that it is the concave surface. So it's a concave surface. I remember this as though like if you're walking into the cave, it's concave. The other way, if the light was to hit on the outside, this we call convex. So concave walking into the cave, if the light is going to go into the cave, convex is going to hit the outside. Okay? Now the way the light behaves with a concave mirror is that it will actually focus into a specific point. So the light, you can see that it's traveling in straight lines. I've used the triple.
So this does a good job. Here is a light source. It has 3 different light beams coming out. You can see how this outside one is bending towards the middle, this one's bending directly back out, and this one's bending towards the middle. So this is just a good representation so you guys can see the light beams coming in and how they behave. So now I'm going to show you the back side. To save time, I'm going to fast forward until she flips it around. When is she going to do that? Here we go.
A convex mirror, here the complete opposite happens. So instead of the rays being focused towards one another, and we ended up with a focal point, this actually causes the light to disperse.
So you can see how because of the curvature of the mirror, the light pushes outwards. All right, back to that focal point. Remember when we looked in our spoon and when we were inside and outside the focal point, the image flipped. So this is a quick little demonstration with a ball, and he has a very big mirror behind him.
This is a demonstration of the image formed by a concave mirror. This is a concave mirror, so it's hollow on the inside. I have this red and blue ball that I'm going to take an image of. The nice thing about this ball is it has a top side and a bottom side, and we'll be able to see when the image is upright and when it's inverted. When the ball, which is the object, is close to the mirror, the image formed in the mirror is upright. So you'll see a ball in the mirror with the red side up, the same as the ball is in reality. As I move farther and farther from the mirror, the image should be getting bigger, but still upright, until we reach the focal point where right at that point the image gets enormous. And then beyond that point, we start moving beyond that point, you'll see that the image is inverted and quite large. And as we continue to move further and further away from the mirror, farther from the focal point, which is right here, the image gets smaller and smaller, but it continues to be inverted till we get out to here. So the focal point is here, roughly where the ball is right now, and parallel rays from infinity that come in and hit the mirror are going to converge on this very spot. There's also another spot that's important for mirrors, and that's twice the distance of the focal point. So we're going to double the distance here, and that's the center of curvature of the mirror. And the way that works is that rays leaving that center of curvature and hitting the mirror bounce perpendicularly off the mirror and come right back to that same spot. And so we can see all this in motion by just setting this pendulum in motion. I'll try that one more time.
All right, so I like this video because if you weren't able to bring the spoon close enough into your eye to see it flip back right side up, you can see it happen in this demonstration. All right, so we just went over the differences between our concave and our convex mirrors. Now I'm going to focus on the eye, because the eye is two convex mirrors. You have your cornea, which is the very outside of your eye, and then the lens, which refocuses the light waves coming into your eye to create a clear image. So if we take a look at our eye, this I'll present here. So here's our eye. We know some of the parts. You probably know that the middle part is your pupil, surrounded by your iris. Do you know what the job of your iris is, though? Your iris changes shape depending on how bright it is in the room that you're at, and will open and close to let the appropriate amount of light in. All right. Your eye kind of bulges out, as you can see here, and that's your cornea. All right. Here's your iris. In the middle, we call the pupil, and then the other lens is right behind it. Now we have basically an empty space of fluid behind your lenses, and all the important cells that determine what you see in color and black and white lie on the retina. So here's another image. We have the cornea, which is the very outside. Here you can see your iris. The black hole in the middle is your pupil, and here's the other lens. We have two convex lenses. They're going to focus the image on the back of the retina, which is connected to our optic nerve, which sends the image to our brain to tell us what we're looking at. So to learn about the eye, I am going to show you a quick brain pop video, and we're going to do some questions together. And that concludes our lesson on the eye. That concludes our lesson today. So let's just take a look at this real quick. So we know we have our convex lens, which is curved outward. And if the light was bouncing off, it would bounce outward. But since the light travels through the eye, we have the light rays converging in the back of the eye. So if I actually go back to this image, remember when we have for a mirror, the light reflects outward. But for a convex lens, or your eye, those light rays converge behind the eye. So when the convergence hit right in the back of your retina, this is the when light is focused and we can see clearly. If that focal point lands ahead of your retina, things appear blurry. And so to correct that, we use glasses to redirect or change the light rays coming into your eyes so that we can refocus those light rays in the back of your retina again so that you can see clearly. All right, so let's take a look at this brain pop video right here. And I am going to exit me out. If it would work. Let me try that again. So it was just working. Let me try this again. All right, so I'm going to start
Hey Moby, have you seen my glasses? I want my contacts. These aren't mine. That's more like it. Dear Tim and Moby, what does it mean to be nearsighted? From Sally. Well, we need to know how vision works to answer your question. Vision is one of our five senses along with taste, touch, smell, and hearing. Light tends to move in a straight line unless something bends or refracts it. When light hits an object, it bounces off and is reflected into your eyes. Your eyes have their own light bending parts called the lens and cornea. The lens focuses this light onto your retina, a light-sensitive tissue at the back of your eye. The retina is made of cones that see bright light and color, and rods that respond to dim light. Hey, see how that image on your retina is upside down? The optic nerve sends that upside-down image to your brain where it flips right side up. In most cases, the lens focuses light perfectly onto the retina, but sometimes people's lenses don't work perfectly and focus the image in front of the retina. When that happens, the image looks blurry and the person is said to be nearsighted. Close-up objects are clear, but distant objects are blurry. Putting a concave lens in front of a nearsighted eye refocuses the light so it converges on the retina. Other people have lenses that focus the image behind the retina. This is called farsightedness because close-up things look blurry and far-away things look sharp. Farsightedness can be corrected by a convex lens. So, nearsighted and farsighted people can wear these corrective lenses as contact lenses or glasses. I wonder where my contact lenses went to. Huh. Moby, give them back.
All right, so let's see how you did. So it says, which of these is not one of the five senses? That would be C, digestion. How does light behave? It travels in a straight line unless it is bent, bounced, or refracted. Correct. What parts of your eye bends light? That would be your lens and your cornea. A 4-year-old child can see better close up than an adult. Fact. The lens focuses light onto the blank. So the back of your eye is called the retina. What carries impulses from the eye to the brain? And that is your optic nerve. What does it mean to be nearsightedness? That means objects are clear up close, but blurry far away. You can see nearsighted. Fact, someone with 20/20 vision can see clearly at 20 feet away. A person with 20/40 vision sees as well as, you're going to finish it, that's fine. What does it mean to be farsighted? So it's the opposite. Objects are clear far away, but blurry up close. What does a convex lens correct? That is looking at our farsightedness. How do you correct nearsightedness? The opposite, with a concave lens. Newborn babies can't see very well. They know their parents by smell and sound. A couple more here. The image is projected onto your retina is upside down. Why do we see everything right side up? Because your brain flips it for you. And then we are done for today. So when we don't have school tomorrow, and when we come back to school on Thursday, Friday, we are going to be working on a poster activity with our sound and light waves. So get ready to draw. You'll need colored pencils, markers, or whatever you need to create a poster. See you on Thursday or Friday. Bye.